And this is multi-step factoring. Multi-step factoring just means that we're going to use one of our 6 methods, but then we're going to have to do another one. Could be the same, could be different, just depends on the problem. A lot of these questions, though, they're just going to have a GCF, and then we have to do something else after that. When I attack these problems, I do them a little different from the other ones. I actually start with the squares and the cubes. So I do all my binomials first. So number 28. Number 28 has a GCF of 8. Pull it out. Write the new problem. X cubed minus 8. So we still have an exponent in there. This is in multi-step factoring. So that means we can actually keep going. This is a difference of cubes. We use the SOAP acronym. Same sign as the original. Opposite, always plus. This formula is AB, AA, AB, BB. To get the stuff on the inside, you cube root it. So the cube root of x cubed is x. Cube root of 8 is 2. A times a would be x times x, so it's x squared. A times b is x times 2, so that's 2x. B times b, 2 times 2 is 4. Take that GCF we pulled out, put it back in front, and we're done. Looks like we have quite a few binomials. So number 22, it looks like it's going to be a cubed, but this has an x also. So we pull it out with the GCF. When you take out the GCF, the parentheses is going to be like your new problem. So you're left with x squared minus 4. So you can see it's not cubes anymore, it's difference of squares. Difference of squares has a pattern where the stuff inside looks the same, but one's plus, one's minus. To get the first parentheses, you just square root each term. X and 2, make a second copy, and then bring down the 5x. GCFs, follow the problem to the end. So you just throw it in the front, you're good. 23, another GCF. 2m squared. 2m squared. So the 2m goes in the front. Here's the new problem. M to the third minus 27. Difference of cubes. Short parentheses, long parentheses. So, same as the original. Opposite, always positive. Formula is A, B, A, B, B. Cube root each term, you get m and 3. So m times m squared. M times 3, 3m. And then 3 times 3 is 9. Then you just pull the GCF down to the front. There's your answer. 24, GCF, 4. New problem, x cubed minus 1, and that x cubed actually has an 8 in front of it still. Cubes, again. So, same, opposite, always positive. Cube root, so cube root of 8 is 2, so it's 2x. Cube root of 1 is 1. AB, AA, AB, BB. So a times a, 2x times 2x, 4x squared. 2x times 1, 2x. 1 times 1 is 1. Pull down the GCF. Just keep it in the front. There's your answer. Next one. GCF is 2b squared. Put that in front. New problem, 8b cubed plus 27. So this problem, again, is a cubes, except this time it's a sum. So using SOAP, same, opposite, always positive. Formula is AB, AA, AB, BB. Cube root gives you 2b and 3. So 2b times 2b, 4b squared. 2b times 3, 6b. 3 times 3, 9. Take that GCF from the front, put it back in the front. There's your answer. Looks like there's one more binomial. GCF is 3b squared. Pull that out. New problem, d squared minus 100. Difference of squares. Two parentheses that look the same, one's plus, one's minus. To get the stuff, you just square root. V10, make a second copy. Pull down the GCF. There's your answer. So that's it for the binomials. So our binomials are done. And I think actually the next one I'm going to do is the grouping stuff. Grouping is easy to identify because it has 4 terms. So 27 is a grouping question, except I don't want to start grouping. I forgot. This is multi-step factoring. Multi-step factoring means there's probably a GCF. So we've got a 2 that we can pull out. Now, because I know what's coming, we're going to have to do some GCF work, and I don't want to confuse it with this original GCF. So I'm going to put this GCF here in bold, and I'll come back to it later. I'm going to leave it there, though. So this is a to the third minus 2a squared plus 2a minus 4. So now we're going to do our grouping work. So we've got split the middle. This would be, actually let me change color so I don't confuse you. This would be a squared. This would be 2. So we have 2a minus 2 plus, just kidding, that's not even a 2 in the front. What am I talking about? Let me start that over. I was almost confused by my red 2. I forgot, I'm going to leave the red 2 up there. I leave the a squared in the front, and I'm left with a minus 2 plus 2a minus 2. There we go. Now we're back in business. I paused there for a second because my parentheses weren't going to match. So here we go. A minus 2. Then we have a squared plus 2. And then the big fat bold 2 that I have up there, I just put it back in the front. There's our answer. Let's see what else we got. Number 29. 29, GCF again. This time our GCF is x. So I'm going to put my x over here, big bold, come back for him later. So this leaves me with 3x cubed plus 9x squared plus x plus 3. We do our grouping. So when we do our grouping, we GCF each set. So this is 3x squared. This one is actually just 1. We don't usually do that, but that's all you can pull out. So we have 3x squared, parentheses, x plus 3, plus 1, parentheses, x plus 3. So our final answer, I'm going to go off to the side here because I'm running out of room. It's x plus 3, 3x squared plus 1. Then we take this GCF, put it back in front. So there's our answer. Let's see, grouping, grouping, grouping. There's one more grouping down here at the bottom. So I'm going to take out a GCF. GCF this time is 3x. Big bold guy here, so I'm going to leave him there. At the end, I'll just reattach him. Now, if you forget to take out the GCF in the first step, you'll be able to take it out in the end. Just look for a GCF within each set of parentheses and then pull those out. So let's see what we're left with. We're left with x to the third minus 2x squared minus 9x plus, is that 20? Just kidding. Just kidding. 18. There we go. Okay. So now, split the middle. That minus, we have to adjust this to a minus. So when it distributes, it's a minus plus 18. Just kidding. I don't know why I keep saying just kidding. Probably because it's almost 6 o'clock. Okay, anyways. GCF. X squared, 9 and 9. So this one is x squared, x minus 2, minus, let's see what we got here, 9, x minus 2. So we have x minus 2 x squared minus 9. We also have the GCF to bring back, so I'll put them back here. But I told you guys earlier that if you ever have exponents left, there's a chance you could keep going. So I noticed there's a difference of squares here. Turns into 2 more. One's plus, one's minus. Square root each term, and then just make a second copy. So our final answer is 3x, x minus 2, x plus 3, and x minus 3. So you've got to watch for that in multi-step factoring. Anytime there's an exponent left in your parentheses, it might be able to break down some more. Okay, so it looks like we're left with some ABCs. So we're done with grouping. So we have to just pull out a GCF because it's hard to tell if it's simple or complex until after we're done with taking out the GCF. Now also, something to note, this problem has a negative. When you pull out this GCF, pull out the negative with it. We don't like to have negatives in front because then all the stuff that we've been doing doesn't really work so well. So here's our new problem. New problem is in blue. B squared minus B, what is that, minus 30. So the problem in blue is now a simple ABC. Simple ABC, make the list. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Try to make 1. So it's 5 and 6. That would be plus 5 minus 6. Simple ABC means go straight to the answer. B plus 5, B minus 6, and then put your GCF in the front. There's our answer. Now, in number 21, I am going to still pull out the GCF in the beginning. Remember I said if you forget to do it in the beginning, you can pull it out at the end. It's actually beneficial to do it in the beginning because then it shrinks all the numbers. It makes it a lot easier to work with. So the GCF here is 3. So this is a 3. I'm going to put this guy as a bold 3. And it's just because I know what's coming. 2p squared. Let's see what else we got here. Plus 5p plus 3. So this problem is a complex ABC. And I'm actually going to make myself a box here so I can cover up some stuff because I'm not going to have enough room to do all that. So let me just kind of cover up this question here. All this stuff. Well, actually, I'll not cover it up because I need that later. Okay. So this is a complex ABC because it has the 2. So that means we need to multiply this to make our list. We need to make a 5 out of those pairs. And the whole problem is positive. So that means it has to be this one. If I use 1 and 6, that adds to 7. So that's not it. Now the thing about complex, it's a lot of work because you have to convert it to a grouping problem. So I put plus 2p plus 3p. Bring down the first term and the last term. Now for right now, I'm going to leave that big fat blue 3 there because I don't want to get confused with the rest of my work. So I'm going to do this grouping stuff first, and then when I'm all done, I'll bring that 3 back into the answer. So this is 2p. This one is 3. So we got 2p, p plus 2, positive 3. Oh, actually, that's not a 2. Let me fix that. It's going to bother me. Go forward 1 step. This is, what is this? P plus 1. I don't know where I got the 2 from. We put the 3 in front, and then this is P plus 1. There we go. Again, I was looking forward, and I noticed the stuff wasn't going to match, so I made a mistake somewhere. So I backed that thing up. Okay, so we got P plus 1, 2P plus 3, and then we bring the original GCF back into an answer. So that's the answer. Okay, looks like we have, please, yeah, we just have one more, and then we got the weird one to talk about. So another GCF, looks like it's going to be 2. Take out the 2. I'm going to make this guy bold again. And it's because I know that when I take out the 2, this is going to be complex still. Complex is going to take a lot of work, and I want to leave the 2 there for a minute. So it's 3x squared plus 11x plus 6. Complex ABC, multiply the first and the last to make the list. So we have 18, 1 and 18, 2 and 9, 3 and 6. We're going to try to make 11. So the only one that can make 11 is this. Again, this problem's all positive, so I put plus signs here. Let me make some more room again with a box. Let's see what we got here. Maybe I can do this right. Up, back down. I want to cover up this problem here so I can have some more space. There we go. Magic. Okay. So we use the pair that we created to make 11, and we're going to use it to replace it. So I'll put plus 2x plus 9x. Then I bring down the 3x squared. Oh, that's getting sloppy. Hang on a second. 3x squared and plus 6. Grouping. GCF. So we've got x parentheses 3x plus 2. GCF is, what is that, 2? Just kidding, it's 3. So then we got the plus 3, 3x plus 2. So this all finally breaks down into 3x plus 2, x plus 3, and then we bring back this guy. So put him in front. There's our answer. Okay. Last question. A lot of people get confused because it's asking for factors. Anytime you can write it as two things being multiplied, that's what factors are. So step by step. 3x cubed minus 12x. So the first thing I'm going to do is GCF. Looks like the GCF here would be 3x. So 3x parentheses, put the 3x over here. This is x squared minus 4. So that's a factor, and that's a factor. So I'm going to go and circle those. I got this one's a factor, and this is a factor. But we're not done. We can actually break up into more parentheses. The parentheses still has an exponent. It's a binomial. It's a minus in the middle. Difference of squares. So this actually breaks up into x plus 2, x minus 2, with the 3x in the front. So we have x minus 2 and x plus 2 also as factors. And that's the whole review. So hopefully you find this useful and it helps you do better on your test.